practice test number 2. That's a practice test. Okay, practice test number 2. So you have the problem I've already posted. I show you those problems. Already got it. So it's already posted on the canvas. Let me show you what type of problems we are going to go over. Okay, this is going to be the practice test number 2. And we are started working with the problem number 1. The topic number 1 that you are going to have over here is going to be binomial distribution. Okay, we give you one problem on the binomial distribution. Okay, so it's going to be the first topic on the first topic on the test, if you like, is going to be binomial distribution. There was no problem from this section on your web assign, but we must know the binomial distribution. Okay, what's going to be binomial distributions? Okay, so that we covered problem number 1 and number 2. Okay, then I have to stop this one to just explain the problem for you. You see, let me just tell you what is the problem. In a case of the binomial distribution, okay, so in the case of the binomial distribution, the situation is that we are looking for a probability experiment in which you are going to have only 2 outcomes. These outcomes would be referred to it as a success and failure. Okay, the probability of success would be denoted by P. The probability of failure would be denoted by Q. And there is going to be a sample size, then we call it N. In this type of problems, this is going to be a kind of experiment that you're going to do it over and over and over. And you are going to be interested in a specific number of successes. So for example, in this, the problem number 1, the problem is if 80% of the population in a community have internet access from their homes, find the probabilities for a sample of 10 people. So we pick 10 people and we ask this question. What is the probability that exactly 6 people would have internet access? At least 6, at most 6. This is always the case. They ask you for 3 types of probability. One of them will refer to the exactly, just one number. The other one is going to be at most 6. At most 6 means 6 is the end. So it's going to be 6, 5, okay, 6, 5, 4, 3, 2, 1, 0. At least 6 is going to be the beginning. For this type of problems, you have to identify what is the probability of success. You see, 80% of the population have internet access. So this 80%, okay, so this 80% would be your probability of success. So this is going to be the P. This is the number that you have to identify for yourself. Probability of success. Then there is going to be given a sample size. This is the sample size. The sample size would be denoted by N. Okay, so N is the sample size, P is the probability of success. When 80% is the probability of success, the leftover of the 100% would be 20%. 20% would be the probability of failure. We don't need it over here, but we can check that one is 20%. So what you have to do, you have to write this expression in symbolic form. Symbolic form means, for example, for the part 1, you are going to find what is the probability. What is the probability that your number of successes? We go with the X because of in the application is X. Some books, they go with the R. So probability that X, the number of successes, to be equal to equal to the 6, or the probability of what is P of 6. That's the first part. The second part, at most. At most means the end. So the probability that X is going to be less than, okay, equal to the 6. Less than equal to the 6 means X can be 0, 1, 2, 3, 4, 5, and 6. And the part C, at least, means the beginning. Probability of X, okay, is going to be 6 up. 6 up. So this is always the condition for the, okay, for the binomial distribution. So what we can do, we can identify this, and then you can go with the formula. If you want to use the formula that we prove, you need to use a calculator, TI-83, TI-84. But the art of stats is very much easy to apply. If you have watched my recording, we can use it also using some tables from your book. But my suggestion is for the test, that application of art of stats. So I'm going to explain that one for you, okay? So if you check the recording, we do it with different methods, TI-83, TI-84, or we did it with just looking at the tables from your book. Okay, so let's go back. I stop sharing over here. So I'm going to classify the problem. So you read the problem, and this is the way you are going to identify your problem. You have to identify probability of success. So you express that this is going to be, it is a binomial case, a binomial, okay, binomial distribution. Binomial distribution, you have to identify 3 numbers for us with probability of success. You consider success to have an internet access. So it's 80%, and 80% is 0.8. If P is 0.8, Q, the leftover, probability of failure would be 20%. 20%, which is 0.2. And the given sample size is equal to 10. This is how you are going to identify it for us. Okay? Then you are going to change the question into symbolic form. The first part, you are interested in the number of successes, okay, number of the people. What is the chance? What is the probability that the number of the people who got the internet access is going to be exactly 6 people? So we would like to find what is P of X equal to the 6. This is the first part. Okay? In symbolic form, the second part would be, okay, the second part would be this. The probability of at most. At most is just the maximum value for the 6. So at most means you are interested in probability of X to be less than equal to the 6, at most. And the part C, at least. At least means the beginning. Okay, at least means the beginning. So this is what you have to find for us. You can do it with the table, you can do it with the TI-83, 84, but the easiest way to do it is that application that we have, okay? So I'm going to bring the applications and then show you. So this is it. I'm going to bring art of stats application that we have, okay? Let me just share it, what I want to do for, okay? Let's go with this part. Okay, or let me find it first, then I come back and share it with you. Okay. So let's say I just started over. So I wanted to see exactly how we are going to get to that. Okay, so this is it. So I go to the art of stats. So we find art of stats. You see, I got it over here because I used it before, art of stats. So go to the art of stats. This is it, one of these. Oh no, that's the wrong one. Art of stats, this is it. This is going to be art of stats. You can have it in your, if you already got it or purchase it on mobile, you can do it. But the easiest way to do it is just the web application. You go to the web application and you have to look for the binomial distribution. You see, you go down, 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 and there you are. You see, binomial distribution and the normal distribution and the t-distribution. We are going to use all of them. For the time being, we are interested in the binomial distribution. So you click on the binomial. Dismiss this. Okay, this is going to be the binomial distribution. It's a discrete distribution. So that's why the result is going to be a histogram. So you are looking for the probability. You click on here, find probability. You see, if you want to find the probability, you have to give us these numbers. The first part is the sample size. The second part is probability of success, which is P. So you put these numbers first. Okay, remember the sample size. The sample size is, the sample size is 10. N is 10. Then you put the probability of success. Probability of success was 80% or 0.8. So that is zero 0.8. Okay, probability of success. Now what you want? You see, the way you are going to have it is this is probability of P of X equal to the X. Look at this. These are four possibilities that you may use. The first one, you are going to be interested in probability of, the first one, probability of X equal to the something. In our case is X equal to 6. The second part is going to be less than equal to. This is where you can get the at most. And this is where you're going to get the at least. And later on, you need the last part, okay, when we get to the normal approximation to the binomial. So whatever you need in this problem, remember the first part was what is P of X equal to the 6. So what you have to do is, I go back, you just give the value of the X. The value of the X is 6. So that would be 6. So sample size of N, probability of success of 0.8, okay, and you want to know what is the probability that you get exactly 6 people. You see the answer is here. Probability that X equal to the 6 would be 0.881, which is which is going to be in this case 8.8%. If you do it with the table or the TI 8384, you will get exactly the same thing. Okay, so that would be very easy to identify. This would be for P equal to the 6. I go back then, I write the final answer for you. Okay, so the sample size, the probability of success, and the X. X is 6, and you are interested in the case 1. Okay, so in the case 1, you get 8.81%. So that would be part 1 of the problem. In the second part of the problem, you want to find when the probability of X is less than 6. Less than 6. Less than 6, that give you 12.09%. So there is something like 12% chance that you get at most, okay, you get at most 6 homes who got the, internet access. And the last part, you wanted the other way around. So this is going to be greater than 6. Greater than 6, you get only 96, you get almost 97%. So 97% of the population would have, more than, so the chance that more than six, more than 6 homes would have internet access would be 96.72%. Okay, that's 96.72. Again, you can do it with the table, okay, and If you watch the recording, there is a table in your book, then you can search it. But this one is much easier to do. Okay, so I go back and I give you this final answer. So what I got, I write it down that I show you. So I repeat that. So this is the first part, probability of x equal to the 6. Sometimes these numbers may be different. Be careful. Equal to the 6. You see, I go back and check it. Equal to the 6. I got point 0. Okay, you have to write the final answer in percent. 881, which is going to be equal to the 8.81%. Okay, in the second part, when we talk about the at most, okay, this is going to be at most. In the case of the at most, the second part, probability that x is less than equal to the 6 is going to be 0.1209, and this is going to be 12.09%. And the last part, a probability of at least the beginning would be given to you, see? At least, in that case, is going to be 96. Probability that x is going to be greater than or equal to 6 is simply 0.9672, which is going to be almost 97%, 96.72%. And then with that. Okay, so very easy case. I stop this one so that we can argue. You see, this is how we are going to get it. Okay, very easy method. But if you want to use the table in your, okay, a table or TI-83, the problem would be it takes a little bit more time to do it. If you watch the recording, the way I probably explain it is this one. You see, if you want to use the table in your book, you have to go, the sample size is 10, the number of success 6. From the table, we get the same number over here. So the first one is easy, 80.1%. But if you want to get this manually, probability that x is less than or equal to the 6, then you have to add probability of the 0, 1, 2, 3, 4, 5, 6. If you want to use the actual formula. So it takes time, but give it the same answer, 12.1%. And if you want to do it manually or with calculator or the other part, you see probability of x to be greater than or equal to the 6. This means 6, 7, 8, 9, and 10. So you have to find these numbers with your calculator and add them together to get something, something similar to what we have. Okay, so this application of Art of Stats is very easy. It's free. You have it on your cell phone. You can use your cell phone as I get to the site, okay, and get these numbers right away. And you just mentioned here that result by the Art of Stats. By Art of Stat, but you have to write it down in this format, not just give us these 3 numbers. Okay, doesn't make sense. But you have to give us this expression, okay? You have to show that you recognize this is a binomial distribution. You have to identify the P, identify the Q, identify the N, and then get the result. Otherwise, you will lose point. Okay, so that's it. In the part D, they ask you which of these events are more likely to occur. As you can see, you just check the probability. The probability of the last one is larger than the other one. So there is more chance that you get the part C because, probability is 97%. So in part D, you explain that the C is most likely to occur. And then you're done. Okay, it's easy problem, but very important in application problems. Okay, so that's the problem number 1 from the binomial distribution. Okay, we give you one of them. We have one more, so I just check that one too, so that make sure that you have no difficulty. So going to the second problem, and this is again a binomial case. So let me bring back that practice test again. And I share it with you. So that would be our problem number 2 here. Okay, problem number 2, again, you read it, you realize it's a binomial case. It was found that 60% of Americans think that having a college degree education is important to succeed in the business. If a random sample of 5 Americans is selected, find these probability. Exactly 2 people will agree with the statement, at most 3, at least 2. Again, it's a binomial distribution because when you ask this question, okay, when you ask this question, you are going to have two answers, whether you believe in this statement, okay, or you believe not in this statement. So there are only 2 outcomes. Therefore, this is a binomial situation. As soon as you get a binomial situation, you have to identify what you mean by the probability of success. This is 60% would be your probability of success, which is P. Okay, so 60% for the P. So for the failure, the complement would be 40%. So P is 60%, Q is 40%. You look for the sample size. If a random sample of 5 people, so 5, N is going to be, okay, N is equal to the 5. So it's a binomial distribution with a probability of success of 60% and the sample size of 5. Now change the problem into the symbolic form. Exactly 2 people agree. So probability of, this would be probability of X to be equal to, okay, X to be equal to 2. Okay, that's first one. The second one, at most 3 people. At most is the end. Probability that X is going to be less than equal to 3. That would be the second case. Okay, and the last case, at least 2. At least 2. In this problem, the numbers are different. So it's going to be X to be greater than equal to. Okay, so that is going to be a situation again. Okay, so it's a binomial case. We just identify the problem. Okay, we organize it, and then we go to the art of stats again to find these 3 cases for you. Okay, so let's go to my notebook and get it done. So that would be problem number 2. Okay, so what is the problem number 2? Again, you have to mention it that it is a binomial distribution. It is a, okay, it's going to be a binomial distribution. Okay, binomial distribution with, you have to identify this for us. Okay, probability of success considered to be 60%, which is 0.6. You have to identify the Q. If the leftover 40%, which is going to be 0.4. And the sample size, in this case, the sample size, okay, the random sample of 5 people. So N is equal to the 5. Okay, now we are going to change the problem into the symbolic form. So in the first part, you are interested in what is the probability that you get exactly, okay, exactly 2 people. You want to find X equal to 2. Okay, this is the first part. In the second part, you want to know when at most 3. What is the chance that you get at most 3 people to be agree with you? So it's going to be X less than equal to 3. So this means you may get 3 people, you may get 2 people, you may get 1 people, or you may get none. Okay, so that's the case. And the part C, at least two. At least two means two up, 2, 3, 4, 5. Okay, again, you can use the TI 8384, or you can use the table from your book. But the easiest way to evaluate, of course, is art of stats. Okay, so I go back to the art of stat, and I'm going to check it again. Okay, so let's go back to that application again. Okay, so I have the art of stats here. So I go back to the applications and I share it with you again to explain it. So this is what we have. Okay, so we're getting back to the application. You go down to the binomial distribution. This is a binomial distribution. And you check for the finding the probability. So that's finding the probability. You put the sample size here in the first part. The sample size was 5. Okay, so the sample size is 5. Then probability of success, 60% or 0.6. So that is 0.6. Then the question that you have. In the first part, you want to know when the probability exactly 2 people. So replace this one by 2. And you are going to have probability, binomial probability when x is equal to. Make sure this is equal to. As you can see, you have it over here. So it's going to be something like 20. Okay, it's going to be something like 2 point. It's a 0.2304. So it's a 23%. Okay, so for the first part, I make a note and then I show you. It's going to be 0.23, okay, 04. So it's a 23.0%. So there is something like 23% chance, 23% chance that you may get. You see that's the graph exactly give you where you can have it. Okay, so you get 20% chance that at least you are going to get you get exactly 2 people who agreed with your statement. Okay, that's the first part. The second part, you want x to be less than equal to 3, at most 3. So change this one into the 3x and go to you see, this is it. You want it to be less than equal to. That's it. Probability that x is going to be less than equal to 3 is 66. Okay. So the second part, the probability would be is going to be 0.6630. Okay. So that gives you 66.3%. Okay, so the chance that you get at most 3 people who agree with you is going to be something like 66%. Okay, for the at least, again, you have to change the number because at least 2. So we change this one into the 2. Okay, and then you go to the at least. Sorry, that's it. That was the 2. You make sure you change this statement. You change this one into the, or that x to be greater than. For the greater than, you get 0.21, 0.910. Okay, see? So it's equal to the 0.919130. So that giving 98.3%. And as you can see, the case 3 is going to be the most likely to occur. Okay, so just very easy application. So let me just go back to my notebook. There you are. So this is the way you're going to write it down nicely. You have to tell us. Don't just give us just number. You have to tell us that this is a binomial distribution. If it's going to be binomial distribution, you have to give us 3 numbers. What is the P, probability of success? What are you going to consider this success, which is 60%, the failure 40%, and the sample size 5. The first part, finding the probability of exactly 2 people agree with you. We got it at 23%. So there is 20% chance that you get at least 2 people who agree with that statement. Then in the second part, you are interested, what is the probability that you get at most 3? At most is the end. Less than equal to 3, this means you can have x equal to the 0, 1, 2, 3. You get 66%. And the last part is going to be at least, which is much, much more. It's clear that, you will find 2 people who agree with you. So the chance is 91%. Okay? So again, if you use it with a calculator, and if you watch my recording, you will see this. Okay? If you do it with a calculator or just a table from your book, this is the sample size in your book. You get the x2 and the p of 60%. So that's going to be 0.3, 0.23. 0.23 would be the same as 23. That's a 23%. Okay, so we get the same answer, 23%, as we have it over here, 23.04%. And you see the next one, it takes times. If you want the probability that x is less than equal to 3, so you have to find the p of 0, p of 1, p of 2, p of 3, and add them together. You get the same answer, 66.3%. 66.3%. But this is quicker. If you want to do the last part, you have to consider p of 2. You see the last part? When x is greater than equal to 2. So we get p of 2, p of 3, p of 4, p of 5. Then you have to add them together to get 91.3%. Okay, but that application, art of stats, is much, much easier. So why not use it? And we let you use this one. Okay, so this is binomial distribution. 2 problems on the binomial distribution. We give you one problem. So one of those 10 problems that you're going to have are going to be cased with the binomial and very easy, to operate. We need this type of idea when we want to talk about proportion. And as I told you, it's not covered on your web assign, which is the wrong one, but we already give you the recording and we are familiar with this one. Okay, so that's why we have to cover it. So that is our first topic. Okay, now we go to the next topic. The next topic that we're going to have is going to be, okay. So the next topic or the next problem, let me just go back and share it again to talk about it. So now going back to the part 3. Now in part 3, what we are going to do, we are going to have a normal distribution problems over here, quite a lot. Okay, we give you a couple of questions, normal distribution. So let's explain it a little bit first, okay? And I'm going to change the order that I'm going to explain these problems for you so that you know what is going on. Okay, so let me just give you a little bit of this idea of the normal distribution, then I come back and do it for you, okay? So that is the first topic. Now, the next topic, very important for the rest of the course, of course, is normal distribution. Okay, what is going to be normal distribution? You see, in the case of normal distribution, in the case of the binomial, x was a discrete variable. This means x can take only, counting numbers, 0, 1, 2, 3, 4, 5, 6. But if you are going to be interested in like in calculus, and you want the x to be any real numbers, in that case, you are going to have a continuous, okay? You are going to have a continuous variable. That continuous variable would be x. Normal distribution is going to be a kind of distribution that would be defined, okay, by a formula that we give you that formula, okay, and the formula seems to be very complicated. So what we did in this case, we just focusing on the graph of that distribution. So there was a function, like in calculus, you see, in calculus, the function is y equal to the e to the negative x squared. Okay, if you graph this one in calculus, you make it something like this. Okay, we call it a bell-shaped curve. But since it's going to be a statistics, we just made this one a little bit more involved. But the normal distribution we identified by the curve, the normal curve. So this is going to be the normal curve. Okay, that was the normal curve. And the center of this curve, okay, the center of this curve is going to be the mean, mu. Okay, mu is population mean. Mu is a population mean, and the sigma is standard deviation. So why we are interested in this distribution and graph? We are interested in because the total area under this curve is 100%. 100%, which is equal to 1. You see, that's going to be the case. And the other thing is the probability and the area under this curve are going to be the same thing. So if you want to find the probability that your income is going to be between $10,000 and $100,000, so when you go here, it's going to be, you see, this is going to be 10,000, this is 100,000. So the area in between these two numbers are going to be the probability that you are dealing with. You know that in calculus 1, the area under the curve can be described by integral. But the integral of this function is not easy to find, okay? You cannot find it by, this is negative infinity to positive infinity, e to the negative x squared dx. You can't find this one right away because you cannot find any antiderivative. That's why we already measured the area under this curve, and we already given you these numbers. So you can have those numbers from the calculator. We can have it with the table, or we can use it art of stats. But in this part, you see, this is the x-axis. So this is x-axis, if you like. But what we are going to do, we are going to use the z-score, remember? So what we're going to do, we are going to change this one. We changed variable, like in algebra. So that's this mean would be happened at the origin. So this is going to be the curve again. Okay, and this is going to be your normal curve. But what we did is we are going to move it, shift it at the origin here. So since this is going to be at the origin, the interchange is happening when using the z variable. Z is equal to the x minus x bar, in this case, x minus mu over sigma. So x would be given to you at the beginning. You are going to change it to the z score, okay? This is z score. So from the x, we go to the z now. So this is going to be z curve. This is going to be the z curve, start with the 0. And then the numbers like, like 1, 1, 2, 3. And this is going to be like the one that you did before, -1, -2, -3. You know that the value between -2 and 2 are going to be ordinary z values, and the other ones are going to be unusual one. So now the same procedure, the total area is 100%. Okay, the total area is 100%, or is equal to the 1. And there is a one-to-one correspondence between the probability and this area and this curve. Okay, so a z number would be given to you, so this is going to be your job. You see, a z number would be given if this is going to be your curve again. So a number for the z would be given. You see, we call it z0. Then if you want to find the probability that p is greater than z0, you have to consider this area. You see, this is the one. So you may be interested in the area to the left or area to the right of the z. So depends which type of probability are going to have. Now, we have different tools to find it. Okay, area to the right, to the left. Your options are going to be, I'm going to, this is from your book, but I'm going to post it in case you want to use it. Okay, so let me show you the Z table. You see, look at this table that we have over here. These are going to be the area to the left of the Z number. Okay, let me bring another one that I have that lefting one so that you can see it. It would be the same thing. Okay. So I'm going to identify it on this one. You see, the way we are going to use this, if you want to use this table, okay, the way we're going to use it, these are the Z values. Okay, Z values. Remember, we write the Z number with 2 decimal place only. So this is 0.1 for the Z. This is 0.10, then this is going to be 0.11, 0.12, 13, 14, 15, 16, 17, 18, 19. Okay, these are the values, positive values for the Z, and these are the negative one. I've already explained this in the recordings. Okay, so these numbers that you see over here are going to be the area to the left of the Z. You see, this is going to be your Z curve. This is going to be your Z curve, and this is Z0. So these numbers that you see over here are going to be the area to the left of the Z0. Okay, area to the left in the Z number. And so, for example, if Z is going to be something like negative 2.2, we identify the, okay, this is it, negative 2.2. So we identify the 2 first, you see, that's a negative 0.20. 2, 2, this is 0, 1, 2. So if Z is negative 2.2, 2.2, area to the left would be this number, with something like 2.17%. So the probability that Z to be less than that number is going to be, okay, that percentage. So this is one way to do it. Of course, you can do this one if you like, but or you can use it with your calculator. But the easiest way to do it, I'm going to show you in a minute, is going to be using the art of stat application. Now there are going to be 3 parts: the number area to the left of the Z, to the right of the Z, or the area in between in all the problems. So what we'd like to do is we would like to check this one first. So that would be problem number 5 that I do first, and then I come back and do the other one. And we give you one on the test. You want to make sure that you are able to read these areas, because this is going to be your job for the rest of the course. All the problems, all the topics that we are going to do, we are going to be related to the Z number. So let's explain this one, going to the number 5 again of the practice one. We do this one first. Okay, I'm going to do number 5 first, reading the table first. You see, look at number 5. Determine the area under the standard normal curve. Standard normal curve is just the Z curve that I talk about it. So what you want to find the area between 2 numbers, area to the right of this number, area to the left of these numbers. Okay, 3 possibilities. To the left, to the right, in between. So for each part, you have to graph it first. You have to give us the graph. Otherwise, we don't accept it. Get the graph and know which part are going to be interested in. And you can use the table. You can use TI 83, 84, or the easiest one is art of stat that I'm going to show you. But you have to graph this. You see, for example, if you want to graph the last part, you have to give us a graph. You see, this is going to be the curve. You identify the number, and then you shade it. This is going to be the area to the left, area to the right, and in between. So I'm going to go back and just do it, and then show you how you can do it with the applications, okay, tools that we have. So let's do number 5 first. In number 5, we would like to determine the area. You see that I'm going to do the part C first. So part C, we want to find the area, find the area. Okay, the area under the normal curve, okay, the Z curve, normal curve, curve to the left of, okay, to the left of this number. The number is Z equal to 0.45. You have to graph it. If you just give us a number, we don't accept it. Okay? So the solution is going to be, you get a normal curve. This is going to be your curve. The center is 0. The center is 0, so this is going to be 0.45. 0.45. Okay, you get the line here. Area to the left. Area to the left is this. Area to the left. Now, area to the left is the same as the same probability of Z. You see, the same as probability of Z to be less than 0.45. It's the same thing because the area and the probability on the Z curve are going to be the same thing. So since the area to the left, if you go to the table, you identify Z equal to the 0.45. You see the first column is going to be Z. This is positive, you go to the positive page. 0.45, you get the 0.4 first. So this is, okay, this is 0.4. Okay, this is 0.4, but you need 0.45, you see? 0.40, 1, 2, 3, 4, 5. So this would be the result. Okay, so the area to the left of the Z equal to the 0.45 is 6736, which is going to be 67%. Okay, so that gives you the area to the, okay, the area to the left, which is going to be 67.3046. Okay, so when it's the area to the left is exactly the same number over here. So I go back, I mention, make a note of this, and then we come back and we do the, okay, we do the rest. So stop sharing, going back to the, okay, so that was the case. So I'll go back to my page and identify it. Okay, so this area simply is, as defined it, is a 0.67, okay, 36. So if you like a probability that Z is going to be less than 0.45 is going to be equal to the, write it down in percent. Don't round it, 67, 36%. You see, this is it. This is the first part. Okay, the area to the left. Then again, you can use your calculator, TI-8384, give you this numbers right away. Okay, but this method, the table is easy. Okay, if you don't want to use the table or this, then I'll go to the art of stats. Again, explain it for you. So let's go back to art of stat because you are going to do it quite a lot, this one for the rest of the course. So let's go back to the art of stats. Okay, this is the art of stats that we have. Okay, now this time you have to go down to the normal distribution. See, this is down, down, down. The first one was binomial, but this is normal distribution. You see the normal distribution. So what you want to do is you better push this again, find probability. You see, finding the probability, you got to be careful over here. This is the mean and the standard deviation for the problem that we are going to have. In this case, just the area, so stay with the 0, 1. Then to check to see what you want. Okay. So in this problem, we have to change it a little bit because let's say showing the z-score because in this form, change it to the, eventually we start with x all the time, but in this case, I just want to use the z. Okay, let's go back to the original one. That's the mean. This would be a little bit, this application needed the x, then because this is the value of, we give you the value of the value of the x. Let's change it. Because of the 0, 1 that you have, this must be automatically the one you are going to be interested in. Let me try it. So the value that I have is 0.45. 0.45. You see that give you the same value here. Okay, that's fine because we stay with the 0, 1. When it's a 0, 1, you know that the origin is at 0. The origin is at 0, so your x and the z would be the same here. Look at this one. So as you can see, and the x value was 0.45. The probability of x to be less than 0.45 is going to be 67.36%, and you're done. Nice, okay, nice and quick to get these numbers. Okay, so we are interested in the area to the right, to the left, and since you go with the 0, 1, the x and the z are going to be the same thing over here, okay? If you change it to the original mean and the standard deviation, they're going to see later on. In that case, we have to write it down. But for the area to the right, to the left, this would be the one. Okay, so this is area to the left. So get the curve. As you can see, this is going to be the graph and then the numbers. So even if you want to use art of stats for the test, you have to give us the graph. Remember, you have to give us the graph exactly as you can see it over here. Okay, that's the case one. Again, look at this formula. This is the area to the left. Greater than would be area to the right. The third one would be area in between. And we have already all those possibilities. Okay, let's go back and explain it. Then we come back and we check it. Okay, so pick the method that you feel comfortable to be able to do it. Okay, table, but the art of stats is the quickest one. If you use the table, is the area to the left for this one. But you will see in a minute, if you want to do area to the right or area in between, you have more work to do. So why not just use the art of stats to do it? So that was the case one. Okay. So this is going to be the case one. Now the other cases that we did have, okay. Now we can go with the B. Okay, part B. Part B, we would like to find the area to the right. Okay, area to the right of the number was given to area to the right of z equal to the negative 1.22. Okay, get the graph. This is it. So this is going to be 0. Okay, 0, 1, 2, 3. And this is going to be again our -1, -2, -3. So identify 1.22. Okay, 1.22 is almost here. That is going to be your Z node. Okay, and this is your Z number, which is -1.22. But you are interested in the area to the right. Area to the right. In the language of probability, you are interested in what is the probability of Z to be greater than -1.22. You see, the Z table will give you area to the left only. If you want to find the area to the right, remember the total is 100%, which is equal to 1. So what you have to do is you have to find the area to the left, okay, area to the left here, and then you subtract it out of 1. You see? So this would be like the complement of the probability. So this is going to be 1 minus probability of Z to be less than equal to the -1.22. Okay, this is the one that most of the people, they miss it on the test if they want to use, just right away, straightforward. And now, if you want to do it as is using the table, okay, this is the table. You have to identify -1.22. You go to the negative number. You identify -1.2 first. Negative, negative, -1.2, 2, 2. You see, 2, 0, 2, 1, 2, 2. So this is the area to the left. 0.11, 11.12%. But so this is going to be, so your answer Z greater than -1.22 is going to be 1 minus, okay, 0.112. Okay, 0.112. And if you subtract it, that give you 0.8888. So you get 88.88%. Okay, that would be your final answer if you don't want to use the application. Okay, but of course, the application is easy case. Okay, so this is just to tell you that if you read your book, I don't know, and they will give you this type of ideas, and especially the one to the right, we are going to use this fact in future. No, but art of stats would give us these numbers right away. Okay, so if you go back to art of stats situation that we did have, okay, so that's a normal curve. Go back to that normal curve that we have. You see, this is the normal curve that we have. In this case, finding the probability again. Find the probability. This is 0, 1. So the value for the x is different now. Change this one. It's a negative number, so it's going to be negative 1.22. Okay, negative, sorry. That is negative 1.22. Okay. Why not? I didn't get that. So the number is negative 1.22. Okay, as you can see, this is going to be a situation that we're going to have. I probably have to refresh this one. So I have a negative 1.22. You see, that's it. So that's the area to the left, of course. You have to check this. You see, you have to change it. You change it to the greater than equal to. You see, this is the number that we find. 11.12% is the area to the left, but you have to find the complement. So that was the wrong. See, that's the area to the right. So the area to the right, as you can see, is going to be 0, 1. No, I didn't. The value of x is here, sorry. X is negative 1.22. That's it. You see negative 1.22, the result 88.88%. So exactly as I did it with the table. Okay, but of course this is quick. But you have the choice. You can do either one, but this one is much easier. Okay, much easier. And this is your reading all the time from now on in this course. Okay, so the area to the right is going to be complement of the left. Complement of the left, this is it. If you give it with the machine, just make sure you change it. You see upper tail that we got over here, greater than equal to. So the probability that the z is going to be greater than equal to this number is almost 89%. Okay, so that's a case 2. Area to the left, just one number, area to the right. Then the last one is the area in between that we're going to use. Let me go back, explain it for you, and then we come back and give you the result, okay? So that was the part B, area. Now the part A is going to be area in between. Area between, okay, between two numbers. Two numbers are given to between the numbers that you have is between z equal to the negative 2.18, okay, and z equal to the 1.34. You see this area between two numbers. So get the graph first. See what type of graph do you have. This is going to be the one. This is your z curve. Identify the 0. The number is negative 2.8. So suppose this is going to be something like a negative 2.18, and the positive, okay, this is 1. You don't have to be precise, okay? So it's going 1.34. So the area in question is this one now. Area between two curves. So from the language of the probability, this means you are interested in what is the probability that z is going to be between these two numbers, okay, 2.18 less than, okay, 1.34. That is going to be the case. Now, you see, again, the z just give you the number to the left. So what you have to do is you have to find the probability of the case for the z number, give you this probability to the left, okay, the area to the left. And if you get this number is going to be the area to the left, then you have to subtract it. You subtracted the larger one minus the smaller. So this would be probability that area of to the left of the bigger number, 1.34, minus the probability of the other one. Okay, the probability that z is equal to the area to the left of both of them. So that would be negative 2.8. Okay, if you want to do it yourself. And if you go back to the table, okay, if you go back to the table over here, you can identify these two quickly. Okay, you have negative 2.18. You identify negative 2.1 first. This is a negative 2.1. Then it's 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. So that give you the 8, almost okay, 0.14. And then the other part is 134. So 134, you identify 1.3 first, 4, 0, 1, 2, 3, 4. So these are two numbers that you have to subtract it. So this is the situation you're going to have. The number for the negative part, you have a 0.0146, and the number for the positive part, you have 0.9099. Then you have to subtract it. So if you subtract it, the final answer is going to be 0.9099 minus 0.0146. Okay, if you subtract it, that gives you 89.53%. Of course, takes times, but it's nice to know how it's happened because you are going to use it in future. Okay, so this is area in between. You have to find each z values and then subtract it. But of course, the easiest part is the art of stats. You can do it with the calculator, but art of stats really is the easiest one. So let's go back to our application. Again, you go back to the normal distribution. You are in finding the probability. You better refresh this one. So the numbers that you are going to use, you have to change this one first because you are interested in area in between. So click on this probability x between x1 and the x2. So that give you value for x1, value for x2. So the value for the x1, the smaller one, is negative. Okay, so that would be negative 2.18. Okay, that's for x1. Then for the x2 is 134. So that give you 34. 134, everything else is the same. There you are. You see, this is exactly how I did it. That's a 1.46 for the lower one. Okay, 9.01 for the upper part. And if you put them together, simplify it, that gives 89.52%. The one that I got is 89.53%. Okay, so as you can see, this is much, much easier. And it's nice, you get a nice graph. But again, if you want to do it on the test, you have to graph it. You give us this graph and the numbers that you got. Okay, you give us this graph, then you can give us 89.52%, and we accept it right away. Okay, and as you can see, the first value, the second value, and everything else is given to you, but you don't need it. So pick the option, but since you are going to use it for the rest of this course all the time, so you better get to use these applications really, because it saves you lots of times. But to knowing it, okay, it's important. It's important to do a couple of them using the table, using different calculators. But since this application is available, so why not use it? Okay, so that would be number 5 on that practice one, reading these areas. Now that will help you to be able to do the actual problem of the normal distribution, okay? So this was just a warm-up, if you like, or getting to know the applications. But we give you one. We give one problem, 3 parts. We want to know how you read this, okay, to get the numbers. Now we go with the actual problem of the binomial distribution type. There are 2 types of problems. There are 2 types. Mostly in your book, there is only one type. The other one is not going to be given quite a lot, but we are going to talk about it. So let's do it in this order. We are going to check the normal distribution first, okay? So I'll go to the number 6. You see number 6, number 7, number 8. We give only one. And these are just for you to practice. So the situation is going to be, it's a normal, okay? So it's going to be a normal distribution. They are going to give you it is a normal distribution. As soon as they give you see, you read the problem. And this is it, given that the woman's weights are normally distributed. Okay, so make sure that we are already uh, sure that you are going to see what I'm talking about. Okay, I get back to the practice one to explain it. Okay, so the normal case, this is it, it's number 6. Number 6 is strategy. Given that the woman weights are normally distributed, as soon as they say normally distributed, you should expect two numbers quickly. The mean, okay, the mean, you highlight it for yourself, the mean and the standard deviation. These two would be given to you all the time. So you identify it for yourself. The mean would be denoted by mu. Okay, the mu is 143, the mean. And then a standard deviation is going to be your sigma. Okay, the sigma for the standard deviation is 29. So that would be the first step. Then the variable in question is, in this case, is the weight. You call it X. They ask you what percentage. Percentage means probability. It's the same thing. What percentage of women weights are going to be between 140 and 211? So this means what is the probability? What is the probability that the weight of the woman, we call it X, is going to be between 140, okay, 140 less than X, okay, and less than 211. That's it. So you identify the question, change it right away, okay, in all the problems. Identify these two numbers first, and then get the symbolic format of your problem. Okay, I'm going to do it, but I'll explain the next one too. Weekly salaries of teachers in one state are normally distributed. What is the mean? Or 90, the mean, the standard deviation, 45. What's the question? What is the probability that the selected teacher would earn more than 525? So this means probability of X, okay, to be more than 525. You see, as we talk about it, for the first one, you have to find the area between these two numbers. You need the area between the Z numbers. You can change the X into the Z, but if you use the application gives you the information in terms of the X, and you get it right away. This is probability that X to be greater than 225. The next one, you see certain models of fully loaded tracks follow normal distribution, the mean of 6.4, a standard deviation of 0.3. X is the weight. So what's the chance to be less than 6 means P of X less than 6, more than 7, and between 6 and 7. Okay? So the important part is reading these problems correctly. So what I'm going to do, I'm going to label it, okay, get the case, then go to the application and do it right away. If you want to do it without application, it takes time. I have the solution, I posted for you, you can check it. But these are going to be easy application because we are going to do it quite a lot of these type of problems, okay? So we just put in action what we learn, okay, with the application that we have. So that's a number 6. The way you are going to do it, you identify what you have. Okay, and this is, again, you have to explain this to us, okay? Change the problem from the word form, okay, into the informative statement, and then you can use the application, not just give us a couple of numbers. So you have to explain that it is a normal, okay, so the problem is a normal distribution. Okay, it's going to be a normal distribution with what is the population mean, mu, is 143. And what is going to be the standard deviation, 29. You have to give us these numbers. So then you change the question into the symbolic form. So what's question? Question, what is the probability What is the chance that the weight of a woman, we pick one person out in the normal distribution. See, we select one woman randomly, and we want to know what is the chance. What is the chance that a woman would have a weight between 140, okay, 140 and 211? You see, that is going to be the case. So change it to the symbolic form and to check to see which of those three cases you are going to have. Okay, so officially, if you want to do it, you have to change it to the Z and do it, but this is case 3, the area between two numbers. So quickly go back to the art of stat with the normal distribution. Okay, so going back to the art of stat. Again, remember, you have to look for the find probability. Find probability. Now be careful. You see that the reading one that we did for was a standard curve. And you have the different mean. Mean is not zero because uh, when you change it to the Z, mean is zero. But since you want to change it, we just stay with the X, you have to put the mean here. The mean for this problem is 143. Make sure you change it. A standard deviation, 29. 29. 29. Okay? So that's for the Z. But what do you want? The case that you are interested in between, you see, between x1 and x2. And the numbers that we have, everything is already there, okay? And so you see, officially, you can change this into the z-score. You get the z-score of 86.16, and these are the values that we have, okay? And there is area between two curves, area between two numbers, and the application is already giving you the probability, 94.99%. Okay, very, very easy to find. So the mean is 140 and the 29. Oh, I'm sorry, I didn't put the X1 and X2. I was shocked that these numbers are here. Okay, what was X? Remember, you want the weight to be between 140 and 211. So this is the smaller number, 140, 140, and this is 211. 211. That's it. This is the area between 2, and the probability that X is going to be between 140 and 211 is 53.17%. Nice. You see, that's going to be the case. Okay, so I repeat it again. Find the probability. You have to bring your mu and the standard deviation. Then you want to find the probability. There are various possibilities. You see, this is the one. And we are interested in the area in between. Okay, so the lower number is 140 pounds, upper number is 211. So the probability in question is going to be 53.17%. Okay, so let's go back and show you how I did it. So I just check this number, then I explain it. So the probability that X is going to be between 140 and 211 is going to be almost 53. Okay, 53 point is 53.77%. So this is, if I pick one person out, one woman out randomly, there is 53% chance that the weight of that woman is going to be between, okay, 140 and 211. Okay, very easy procedure to get these numbers. But you see, if you want to do it yourself, if you don't like the application, but you have to pay for it, it takes times. This is what you do. I will post this so you can have a look, but try to use the application. It's much, much easier. You see, if you want to do it manually, These are X. You have to change them to the Z first. So you have to use the Z-score formula, Z equal to the X minus mu over sigma. Okay, X minus mu over sigma, and then you change them. You already got these numbers on that application. So the corresponding number, so it's going to be negative 0.1, and this is going to be 2.34. And you already got both of them in the, in your application. So you have to find the probability that Z is going to be between negative 0.1 and 2.34. You go to the table, you find this number subtracted. This is, almost the same. Probably I made maybe this a couple of decimals, but it would be the same thing. So I did it with the calculator. This is TI 8384. With the calculator explaining 140, you see the calculator give you 53.17%. So calculator, manually, okay, manually, of course, using the table and the art of stats. Pick your choice. Which one are going to use, okay? But the easiest one is art of stats, okay? But whichever you prefer, we accept it right away, okay? So with the art of stats, again, you have to give us, it's a normal, okay, it's going to be normal distribution with this condition that you're going to have, and you just use the application and you find the answer, and we accept it right away. Okay, that's number 6. The other ones are similar. So let's try the other ones that we have in this case. Okay, so let me just go back to the practice one again. And I bring the other numbers. There are 3 possibilities. Maybe we give you 1 or 2. So that was the first possibility is in between. The second one, this is number 7 that we are going to do. Okay, number 7 is about teacher salaries, normal distribution. Okay, this is a normal distribution, and you have the you have the mean of the 490 in this case, okay? So mean of just check to see if I have the other solution for you, okay? Okay, I don't have and okay, this is it. We're just going and using that table right away, okay? So let me just write the information, then I go back to the, so that's it. The mean for 90, standard deviation 45. So the situation is more than, you see, more than. Be careful, more than means P of X to be, okay, P of X to be greater than 525. Okay, 525 is going to be area to the right. So I go back to my notebook and I explain it, okay? So this is going to be number 7. Then you are going to tell us that it is a normal distribution. Normal distribution. Normal distribution with, you have to identify this for us, okay? Mu, the mean is going to be, this is the salary of the teachers, okay? Weekly salaries, the first one is $490. And the standard deviation, sigma of $45. So again, we pick one teacher randomly, and we want to check whether, what is the chance? What is the chance that the salary of the teacher X is going to be more than $525? Okay, that would be area to the right. So what you're going to do, you go back to your, to your art of stat application, okay? Otherwise, if you like to do it yourself, that we don't, okay, recommend over here. Okay, so we go to the normal curve again. So there you are. We are the, just make sure that I have the shading here. And make sure to shade the proper one. So that would be our normal curve. Okay, refresh your normal curve. You want to find the probability. Again, you have to give us what is the mean. The mean in this case is 490. So that would be 490. That's the mean. A standard deviation of salary is 45. So that would be 45. Okay, and the question is more than 525. So the case is going to be more than, that's a more than, and you have to give us the value for the x. The value for the x is 525, 525. There you are. In case of 525, it's going to be the area to the right and the probability of 21.84%. If you want to do it yourself, you have to change the x into the z first. This is the z number. Then you can use the table that I gave you. And this one, of course, is much, much easier. Okay, it's going to be the area to the right. And the final answer is 21. Okay, so the answer is 21.84%. Okay, stop shading and checking the numbers. There you are. So out of stats solution give you probability is going to be 525 is going to be 21.84%. So if you pick one teacher randomly, the chance is, there is a 22% chance that teacher earn $525 per week. Okay, so this is going to be kind of a second case. Okay, and give another one so that you know how to do it for the next one. Yeah, okay, so let's check this one. The next question is going to be, this is a kind of most likely one that we usually ask because we ask all the three possibility at once, okay, in one problem. So, because it's three choices and you can do it with the calculator right away, okay? So that's a number 8. The situation is we talk about the certain fully loaded tracks. They say it's a binomial distribution with a mean of 6.4 tons, a standard deviation of 0.3. So X is the track weights. So we want to know if you pick one track, what is the possibility that that track would have less than 6 tons, more than 7 tons, and between 6 and 7 tons, okay? So you set up the problem. Okay, we set up the problem here. This is number 8. Setting up the problem, so it's a normal distribution. It is a normal distribution. With the variable X is going to be track weight. Weight. You have to explain this for us, okay? The mu, the mean is 6.4 tons. Okay, and the standard deviation is 0.3 ton. Okay, that's the case. So we pick a one size, sample size is 1 in all these problems. So we pick a one track out and we ask this question: what is the chance that the probability of weight X is less than 6 tons? So that's the first part. The second part, what is the probability that it's more than 7 tons? And the third part, what is the probability that X is going to be between 6 and 7? You see, in all cases, if you want to do it yourself, you have to change them into the Z first, okay? Z numbers, then go draw the table and you get it. But we have our application. So we go to the application and we check each one of them one by one. Okay, so let's go back to the Art of Stats application. So that would be that normal distribution that we have already. Okay, so I'm going to share that again. That's a normal distribution curve. Then refresh your finding the probability. So bring your mu. Your mu is 6.4. So that give you 6.4. Okay, that gives you 6.4. And the standard deviation of 0.3. So that give you okay, 0.3. That's it. Then the case one, for that x to be less than 6. And okay, less than 6. So the value for x is 6, but less than. That's greater. Less than, area to the left. So in the case of the less than, the probability would be 97. Okay, 97.50%. 97.50%. So the chance that the lorry load is going to be more than 6 tons is going to be 97.5%. Okay, so that's the case one. The case two to be greater than 7. And the mean and the standard deviation is the same. You have to change this one into the greater than, and you have to change your number. I'm sorry, that number. Let's just double check the previous one first. Okay, this number was less than 6. You see, this is a less than 6 only. That's a less than 6. So that is 9.12%. Okay, that number was not correct. Okay, double check it always. Is a 9.12%, almost 10%. So there is almost 10% chance, 10% chance that the Larry Bait is going to be, okay, 10%. It would be less than 6 tons. Now we go to the 7. So we change this one into the 7. So do it manually, 7. But you want it to be greater than, it's area to the right. Greater than, you see area to the right. So that gives you 2.5%. So in this case, this is going to be 2.5%. Okay, so that's the second case. The third case is between 6 and 7. So you go to the third case, that change the numbers. The first one is 6, and the other one is 7. Okay, so that give you 7. 6 and 7 is going to be the area in between. Area in between, and that's going to be the greatest value that you get. You get 88. Okay, 88.6%. Okay, double check it, yourself again to just make sure these numbers that I got are all okay, are going to be all correct, if you like. But this is going to be a situation. You see the normal distribution, easy case really with this application. So expect something like the part 3. We give you all the numbers. So just use the application and then everything is clearly given to you. Because today, really, when you get to the application of this problem in your everyday life, whatever discipline you are going to have a bunch of data that are going to be dense, large. So it's not the case that always you have 4 or 5 numbers you want to add, subtract. So that's why be focusing on the applications that it's going to be very useful. Okay, so that's the number 8 as we talk about it. And write it down as I did. Okay, nicely. You have to change the question into this format. Probability of x is less than 6, 10%. bigger than 7, 2.5%. In between, this is the one, 88.60%. Okay, just double check these numbers. Yes, uh, make sure that we have something, something true. Okay, I'll double check it again when I want to post it. But I think it's correct because I don't have this one. I didn't check it before, but it should be all right. Okay, so this is going to be the normal distribution case. Okay, so that's a case one. The case one, these z numbers are given to you, then the question of the probability. There is another application of the normal distribution, which is quite interesting. You see, in these problems, the z numbers or the x values is given to you, you find the probability, which is the area under the curve. But we need to know the reverse order, if you like, and the other way around. So to do it the other way around, a kind of percentage would be given. Then we would like to find these x's, okay? What is going to be the z numbers? Is usually used, you see, when you buy something, they give you a warranty. They say the warranty is 2 years, 4 years. So if anything happened to your purchased items, okay, less than 4 years, then they have to pay for it. They have to renew it, replace it. But we want to know how you set up those 4 years, 2 years, because the companies, they usually like to give you only, okay, the free case, something like at most 10%, or most of the time 1% or less than 1%. So we want to know how they are going to set up these conditions. Like when you order a pizza, they say, oh, it's arrived less than 10 minutes and it's going to be hot. So how determine these type of things, okay? So that's quite interesting. You can do it manually or you can do it with this application, but you have to set up the problem correctly. So what I'm going to do, I don't have time at the moment, so I'm going to stop this one and then I give you a second, okay, a second recording that will be cover the rest of the problem. Okay, so have a good one so far, but I will do that one just later on. Okay, have a good one. Bye bye.